Okay. So section 6.6, remember on Thursday, pretty much our main objective was to take a radical expression, right? And to kind of rewrite it from that radical to exponential form and vice versa. So we kind of worked back and forth between each of those. We're trying to understand what our roots were telling us. So you see here, we have some very generic square root expression, x to the b, and taking the eighth root of that, right? So a is my index, that tells me what root I'm taking, b is the power, and then x is either the variable or the constant term, all right? And we said that we can go from this expression, so the radical form, to the exponential, or you heard me say rational, fractional, pretty much all means the same thing, to go to that form, which is when we take the degree, divide it by whatever that index is, and we write it with that base of whether it was the constant term or the variable term, right? So if we need a more concrete example, just to kind of refresh our memories, if we had like the fourth root of x cubed, we said that that was the same thing as that base, so the x, and then the degree on the inside divided by the index, so 3/4, right? These are both the same thing. One is just the radical form, one is the exponential form, okay? And we did a lot of practice with that on Thursday. We actually did a really, really nice job with that when I was going through and checking, and even on your checks on Friday with being able to kind of rewrite things, and we really took care of that objective, all right? Are there any questions about that idea? Do you want me to kind of explain how to do that again, or is everybody clear with what we're doing there? Everybody good? Because today what we're going to do now is add a layer on top of that, where not only are we going to kind of rewrite between radical to exponential form, but we're also going to use that now to kind of help us simplify expressions where we're either multiplying or dividing two radical terms together, okay? So we saw this a little bit back in chapter 5 when we were working with polynomials and simplifying them with multiplication and division. Well, now we're going to see it where we start with a radical and how we're going to use these exponent rules to help us, all right? So towards the middle of the page, we kind of want to go over what some of those rules were. We had the product of powers, which is when we have some, variable or number, that base, raised to an exponent. We're multiplying that by the same variable or the same base raised to a different exponent. We add those exponents together, right? So you see some examples off to the side. I have 3 squared times 3 to the 4th. Well, that's the same thing as 3 to the 2 plus 4, or 3 to the 6th power, right? If we're dealing with a variable, p squared times p to the 9th is the same thing as p to the 2 plus 9, or p to the 11th power, right? So one thing that you might want to note, just to kind of solidify this point, is that when we are multiplying exponents, we add. So we're multiplying those exponential terms, we add the exponents together. Okay. Any questions about that first property? So you multiply the exponents, you're adding them. The second property we had was the quotient of powers, which is now when we're dividing two exponential terms. So I have, some base raised to 1 power divided by some base raised to another. Now I subtract the exponents, okay? So you see here in these examples, I have 9 to the 5th power divided by 9 squared. Well, that's 9 to the 5 minus 2, or 9 to the 3rd power, just subtracting those exponents. When we're dealing with a variable, the same thing applies. So the same rule, b to the 6th divided by b to the 4th. Well, that's the same thing as b to the 6 minus 4, which is just b squared, right? And as we go through today, it's important that we make sure we simplify those as well. So one note that you might want to make, when we are dividing those exponents, we subtract. Okay. So just to kind of solidify that point, multiply, we add, divide, we subtract. Are there any questions about either of those two exponent rules? Everybody good so far? Okay. So let's jump down now and kind of see how we're going to simplify these radical expressions. The first and the fourth question we've already gone over in some other sections. So I kind of just want to focus our attention on numbers 2 and 3. Okay. The first thing that we're going to do in each of these is convert from radical form to the exponential form. So we can be able to use and apply these rules to help us simplify, right? So in the first two examples, I'll kind of go through each of these on my own, and then we'll, kind of move on from there. I have the cubed root of x to the fifth times the cubed root of x to the first power, right? My first step, and I'll zoom in just in case it's tough to see the exponents. My first step is to convert this term to exponentials. So I know I'm going to have that base of x. It's going to be the degree divided by the index. Well, my degree is 5. My index is 3. So this is x to the 5/3 power. Just rewriting it similar to what we did on Thursday and Friday. I'm multiplying that by x to the, well, there's really no power written in there, that it's assumed it's a power of 1. My index is still 3. So I have x to the 1/3 power. Any questions about how I rewrote those? Well, when I'm multiplying same bases and they have exponents, I'm adding them. So this is really x to the 5/3 plus 1/3, which is x to the 6/3, which is x squared. Good. Bless you. So just simplifying as far as I can go with my expression. So that's x squared. Okay.
Where'd you get x squared from?
6 divided by 3 is 2. So I go from x to the 6/3 to x squared. So I'm simplifying that exponent. You can simplify exponents if they have fractions that you can break down further. Does that make sense?
Yeah.
Okay. Any questions about the first example? Second example, very similar. So I have 8x to the fifth, taking the square root of that. Well, that's the same thing as 8x to the 5/2, right? Take the degree divided by the index. Remember, when the index isn't written there, it's assumed that it's the square root, which is an index of 2. And I'm dividing by 2 x to the, well, the degree here would be 1. The index, again, is not written, but it's also 2. So it's 1/2. Any questions about how I rewrote that? Okay. Now I'm going to use my quotient of powers rule. Remember, when I'm dividing and I have those exponents, I'm going to subtract. Well, I can still divide these constant terms together the same way. 8 divided by 2 is going to give me 4. And I'll have x to the 5/2 minus 1/2. Well, 5/2 minus 1/2 is 4/2, which means I'm left with 4x squared. 4/2 again, I can simplify. 4 divided by 2 gives me the 2. So I have 4x squared. Any questions about either of those first two examples? Pretty good. Well, one thing that we can notice about each of those, in number 2, my index is 3 for both, right? For either of those two terms that I'm multiplying together. And number 3, my index is 2 for the two terms that I'm dividing. It might not always be the case that we have the same index. And what we're going to take a look at now is the process and how it might change just a little bit when we have something that maybe we're taking the third root and dividing it by something with the fourth root. We're taking the square root, multiplying it by something with the fifth root, and kind of the steps we need to take to simplify that further. All right. So you flip over to the next page. We're just going to take care of this top half. All right. So going through the steps to kind of see what happens when we have different indexes. All right. And what I plan on doing is kind of using example 1 to help guide our steps at the top there. So we're kind of doing a step, filling it out, similar to what we've done before in class. All right. So step number 1 says change each radical to a, that should say, rational exponent. Or you'll hear me say fractional sometimes as well. So I'm going to write both of those in. Rational or fractional exponent. So very similar to what we did at the end of last week, just rewriting them so they have an exponent, right? So if I take a look at example 1 there, instead of the square root of 3, I'm going to write that as 3 to the 1/2 power, right? 3 has that exponent of 1. The index is technically 2. So I'm going to convert that. And I'm multiplying that by 3, again, same base, raised to the now 1/4 power. Notice that my index is different in that second term. Okay. Any questions so far? Step 2, and I'm then going to, simplify using exponent rules. So the 2 exponent rules we talked about on the front, when we're multiplying, we add. When we're dividing, we subtract. The only thing that we need to remember in that note that's underneath that, the bases must be the same to use these rules. So notice here I have a 3 and a 3 as the base. If they are not the same, you have to use some of your exponent rules to kind of convert. Okay. So always check to make sure you have the same base, which I do. And then I'm going to go through and use my exponent rules to help me simplify. Well, this is really 3 to the 1/2 plus 1/4, right? When I'm multiplying them together, I'm adding the exponents. Notice that the difference, though, between the first 2 examples we talked about today and the last, in this example right now, is that they have different fractions, right? When they have the same index, they have common denominators. It's easy for me to add or subtract, excuse me. The only added layer I have to do here when I'm simplifying, which is my 3rd step, is to change those fractions so they have common denominators, right? So if I'm going to do that, I have 3 to the 1/2 plus 1/4. Common denominator would be 4. So I'm going to change 1/2 to 2/4. Keep the 1/4 the same. And this is really 3 to the 3/4 power. Any questions about how I got to that point? Well, one big piece of step 3 is to simplify it, which we did, but then we want to write our answer in either exponential or radical form. I would suggest, if you can, putting it in radical form. And the reason for this, I'm going to draw an arrow just to make an extra note, is that you can simplify a little bit further from this form. Right, like I would never want to leave my answer as x to the 1/2. I would want to leave it as the square root of x. Just a little bit cleaner in our notation. Also, if we're dealing with a number, like you wouldn't want to leave it as 9 to the 1/2 power. That would be the square root of 9, which we know simplifies to 3. Okay. So that's something that I can do in this example. I have 3 to the 3/4 power. Well, up above here, just draw another arrow to finish my problem. That's the same thing as the 4th root of 3 cubed. Well, what do we know 3 cubed is? What's 3 times 3 times 3? 27. So this is how I'd want to leave my final answer. Okay. Any questions about that first example? Notice that the only real difference here is just the ability to make sure you have common denominators. And if that's a skill that you struggle with, make sure that you're asking questions along the way too, as to how we got some of those exponents that we are dealing with. All right. Any questions about the steps or that example before we move on? Okay. Example 2, very similar. And as we go through this, we could be a little bit more collaborative, right? So how would I change the numerator, that square root of x cubed, to an exponential expression? So that's x to what power? 3 over 2. What about my denominator? That's x to the 2 over 3 or 2/3 power. When I'm dividing, what operation am I doing with my exponents? Subtraction. So I have x to the 3/2 minus 2/3, which is really x2. Well, now I have to have a common denominator. What's the common denominator between 2 and 3? 6. Good. Well, I get to 6 by multiplying 2 by 3. I'm going to do that in my numerator as well. So I get 9/6. Get a common denominator of 6 by multiplying 3 by 2. I'm going to do that in my numerator. I get 4/6.
Wait, so how did you get that?
What's that?
How did you get 9 and 2?
So when you're converting with a common denominator, right? We said the common denominator was 6. So for this fraction, 3/2. If you want to have the denominator be 6, what do you multiply 2 by to get to 6? 3, right? And then whatever you do in your numerator, or your denominator, you do in your numerator. So 3 times 3 gives you the 9. Same thing with the 2/3. So 3 times 2 gets me to 6. So the 2 times 2 gets me to 6 as well. Or it gets me to 4, excuse me. 9/6 minus 4/6 gives me 5/6. And then to finish my answer, I'm going to write this in the radical form. So it's going to be the 6th root of x to the 5th power for my final answer. Okay. Any questions about that example? Okay. Example 3. So hopefully we're kind of getting into the groove of this now. How would I convert that first term to exponential terms? Maybe let's get somebody from home to help me out with this one. The first term here, so the square root of 11. That's 11 to what power? Somebody from home. Somebody in here. Square root of 11. It's 11 to the 1/2 power. Good. Times 11 to what? 1/3. Good. When I'm multiplying, I'm doing what with my exponents? Adding. So I have 11 to the 1/2 plus 1/3. Well, what's the common denominator there? 6. Good. Does everybody see how we got to that point? Well, how do I convert 1/2 to to a fraction with a denominator of 6? The 3/6, so it's 11 to the 3/6 plus 2/6. Good. Which is 11 to what power? 5/6. And I'm going to finish writing my answer as the 6th root of 11 to the 5th power. Now, although we have a number underneath our root here, 11 to the 5th power, I'm not going to write out what that is. I can just leave it as is. When it's something like 2 squared, write it as 4, right? Or 3 cubed, like we saw in the first example, write 27. But I'm not going to have you do that for every single problem. Okay. Any questions about the first 3 examples? We've seen some multiplication. We've seen some bases that were variables. We've seen some bases that were constant terms. Everybody okay with these ideas so far? Okay. The next example is a little bit different. Notice that we have 2 variables here, right? Our steps don't necessarily change. It's just a matter of understanding what we can combine versus what we can't combine when we're either multiplying or dividing, right? We talked about this back in chapter 5. We can only work with things that have the same variable. And then we go to their exponents and go through our rules. Still going to change each radical to a rational form or fractional form. So a to the 3rd, I'm taking the square root. Well, that's a to the 3/2 power. B to the 1st, I'm taking the square root. That's b to the 1/2 power. So I'm still going through and changing these the same way I did before. Just take it variable by variable, right? Don't try to do too many things at once. Okay. I'm multiplying that by a to the 2/4. Well, what's 2/4? Simplified. 1/2, right? If you can go through and kind of skip some of the simplifying so you can get those common denominators easily, I would suggest doing that first, right? Otherwise, you're kind of rewriting and going through steps over and over again. B to the 2/4 power, that's b to the 2/4 or 1/2 again. So that's my second term written in exponential or fractional form. Okay. Any questions so far? All right. Now what I'm going to do is add, but I can only add, because I'm multiplying, the a's together and the b's together. So I have a to the 3/2 plus 1/2. Well, 3/2 plus 1/2 is 4/2, which is just 2. So I get a squared. B to the 1/2 times b to the 1/2. Well, I'm adding those. 1/2 plus 1/2 gives me 1, or just b. So my final answer here is a squared b. So like I said, we need to be, very in tune to the fact that we can only add things that have the same base. So the a's with the a's, b's with the b's. If there was another variable, c, for example, you would add those together, right? Have to have the same base. Any questions about that example? Okay. Next two just have one variable, so we can go back to kind of working together here. What is the exponential form of that numerator? X to the 3/4. The denominator would be x to the 2/8. Well, what's 2/8 as a simplified fraction? 1/4, right? Like I said, you can kind of go through and skip that step of rewriting it if you know that it can simplify. Well, this is x to the 3/4 minus 1/4, which is what? x to the 2/4, x to the 2/4. Wow, is 2/4 simplify? What's that? To the 1/2. Before I write the final answer, are there any questions about how I got to this point? X to the 1/2, I'm going to write this in radical form, right? I'm going to try and put all of my answers, if I can, in that radical form. Well, that's just the square root of x, right? I wouldn't want to leave it as x to the 1/2. Write it as the root of x. Any questions about that example? Okay, my last example. Convert each of those to that exponential form. What would the first term become? Y to what power? 5/3, good. Times y to what power in the second term? 4/3. When I'm multiplying, I am doing what with my exponents? Adding, good. So I have y to the 5/3 plus 4/3, which is really what? 9/3. And what's 9/3 simplified to? Great. Again, you wouldn't want to leave it as 9/3. You write it as 3. Now for this one, because it's a whole number there, I can't convert that to my radical form. I would just leave it as is. Whenever it's a fraction, that's the time when you want to convert it to the radical form. Okay. Any questions about any of those examples or anything that we covered in class up until this point? So, like for example here, right, I was left with x to the 1/2 power. So I know that that's x to the first, and I'm taking the square root. So I can put it in a square root. Here, 5/6, 5/6, 3/4. Whenever your final answer has a fraction as its exponent, that's a good sign that you can put it into radical form. When it is left with a whole number, like here, so a squared b to the first, there's no other power there. There's no fraction. Here, y to the 9/3, we converted to 3. So it's a whole number. I don't have a fraction. I can just leave it as is. But when it has a fraction, say 1/2, 5/6, 3/4, whatever it may be, that's what time that you can convert it to radical. Good question, though. Any other questions? And again, the reason for that too is so we can simplify a little further. Like here, it's 3 cubed. Well, that's 27, right? We want to simplify as much as we can. Okay. We still have about 12 minutes here in class. What I want us to do, if you go to today's folder, so those of you that are in here, you make sure that you access this as well, whether it's on whatever device you're using. So as long as you can pull up Schoology and get this done, I would suggest laptop, but whatever's easiest. There is this 6.6 day 2 check. So it's 2 questions. Oh, that is the worst sound. 6 questions. Or not 6 questions, sorry, 2 questions related to what we did today. So there's one multiplying and one dividing. It's multiple choice, so make sure that you go through, show, you don't have to necessarily, show your work, kind of go through the process on a separate sheet of paper. You don't have to turn in your work, but make sure that you show it. And then choose the best answer choice. This is going to allow me to kind of make sure that we know what we're doing. When we go into our practice tomorrow, kind of either review some concepts or we can kind of dive deeper and do some more challenging problems. All right. So take the next 5 to 6 minutes or so, get those 2 questions done. I'm going to go through and just check to make sure everybody's on task. And then towards the end of class with like a couple minutes left, I'll explain what the homework assignment is for tonight, and then we'll wrap up for today. All right. So what I need you to do now is just go through that check. I'll kind of walk around the room, see if you're struggling. If you have any questions, let me know. And then in a couple minutes, we will go over what the assignment is later. Check. Did you do this yet? Did you do this yet? Yeah. All right. Just wanted to make sure you're doing what you're supposed to.